So here's an exercise that will introduce our next topic. So pause, copy, and calculate these three things for me. Pause, copy, calculate, pause, copy, calculate. Okay, so if I do E1 times A, what do I get? I get just A, B, C across the top. D, E, ooh, I need to leave more space, don't I? Let's spread out the B and the C here. B, C, D, E, F. And then on the bottom, something else happens. What do you get? Well, you get G minus 4A. And then H minus 4B. And then K minus 4C. 4C. Okay, let's pause and look at that. What happened? Well, if I look at that bottom row, I can see that this is reminding me of something. It's like I just did row 3 minus 4 row 1. That's interesting. Okay, what about the next one? E2. What happens with E2? Looks like it's a scaling, isn't it? You're multiplying the last row by 5. Um, 5G, 5H, 5K. This is same as doing 5 row 3, 2, A. And E3 times A, that's going to be my switching the first two rows, right? D, E, F, A, B, C, G, H, K. The alphabet is fun for me. Row 1. Oops. It's right over here. Same. Row 1, interchange row 2. 2. A. Okay, pause. Copy all that down. Let's talk about what this means. Let's say a few things here. E1, E2, and E3 are called elementary matrices. Next bullet point. Every elementary row operation okay, so the elementary row operations are replacement, scaling, interchange. So we can see from the above that every elementary row operation has a corresponding elementary matrix. Elementary matrix. Okay. Okay, so what are we doing this for? Well, we want to prove of our algorithm for finding A inverse. I want to use this information about elementary matrices to prove this somewhat mysterious looking algorithm. Those are my quotation marks there. Okay, so where do I start? I start with, well, so what does it say? It says that if A can be row reduced to give I, the appropriately sized identity matrix, then I should be able to, there exists an inverse matrix. Okay. So what does this mean? So I'm going to use this symbol. This arrow says to me, therefore. So A can be row reduced to give I. What does that mean? That means that I can do a sequence of elementary row operations to A and eventually arrive at I. In terms of elementary matrices, I'm going to write that as, you know, this this product here. So I got E. So there is some product of elementary matrices such that when I multiply A by it, I'm going to get I. Okay, let's go through the logic again. So this would represent the first elementary row operation that I would do to get from here to here. And this would represent the second one. And so on and so forth. And we'll say there are K, a total of K elementary row operations that bring me from here to here.